Okay, in this lesson we are going to handle a different type of queries called summary queries. Until now, all the queries that we talk about were returning just data row by row. Sometimes they were putting filter, other times they were calculating fields, but the data were always row by row, so record by record. No global record operation was performed. Summary queries are queries which perform global record operation. For example, they're able to count how many records you have, to sum a value through the records, to calculate the average, the maximum, the minimum, and other small statistical functions. So they're able to make, let's say, vertical operations, operations which involve several records which are grouped together. This is the reason why you will see appearing group by. Let's see. First of all, we open Northwind as usual, this one. Okay. Create. Okay. First query. Build a query which shows the categories and for each one the average cost of products in that category. Well, as you can see, it's a query which doesn't simply have to display something, but has to do a calculation in the vertical direction. I mean, it has to sum up all the prices and divide by the number of elements in each category. Okay. So let's see how to do it. Whenever you have to build a summary query, first of all, you must build a simple query which extracts the data that you need. Then you apply the summary operation. This is the best strategy. You can do everything in a single step, but I don't suggest it to do. So query wizard. For this specific query, I need from table categories, the category name, and from table products, well, product name and unit price. Next. Okay, you can build summary queries from here, but I don't suggest you to do. Well, maybe it's faster for you, but I honestly prefer always to do, let's call it query 21. Okay, so what do we have to do now? We have to group the things here in beverages, okay, and calculate the average price. In order to do it, we switch to design view. Well, first of all, I remove product name. I will explain later why. Okay, so product name is not necessary. I'm not interested in which product, so I remove it. For what is concerning unit price, I need to calculate an average. How can we tell him? You must click here on totals, and a new option appears, total, and you tell him average. So we are grouping by category and calculating the average of unit price. Always check what's in the total, because this changes a lot. So grouping by categories and calculating the average of unit price. You click on run or switch to datasheet view. And it's very simple, you have the categories and the average. So what has Access done? Access has compacted, let's remove the thing and see. Access has compacted this, how many? 2, 4, 6, 8, 10, 12 rows into one and has calculated the average of this one. Okay, exactly as we were telling him here. Group by categories and calculate the average. Okay. Why did I remove product name? Well, let's restore product name here. Okay. If you leave product name, what happens? Well, it happens that Access is not able to group the things because you are telling him to group by category name and group by product name as well. But there is no record which has the same product name, so all the records remain independent, as you can see. So this is especially true for summary queries. Never leave fields which you don't need, because they only create confusion and they only prevent correct grouping. Okay, modify the query, adding the product names. Okay, here this is what we have done right now. Modifying the query, counting how many products exist for each category. So now, instead of calculating the average, I just want to count how many products exist. Okay. Or better, not instead of calculating the average, but also, so I want to calculate the average and count how many products. How can I count how many products exist? Well, the best way is taking the product ID and choose from here count. Okay. I must tell you, it works even if you choose another thing. Even if you choose reorder, level, or discontinued, it works. Okay, but it's theoretically wrong. Okay, so if you do it at exam and it works, good for you. If you do it at exam and it doesn't work, don't blame me. So I've chosen product ID because whenever I count something, I want to count the ID because I'm sure that no problem happens. Because for each ID there is one item. The correspondence between ID, primary key, and item is perfect. So I count always the primary key. If you count another field, I'm rather confident that it should work, but if it doesn't work, don't blame me. Okay, so you can see it has count. In practice, it has counted that for beverage, there are 12 different primary keys. Okay, so you have 12 different products. Okay, just to show you, if you count discontinued, which is totally meaningless from a theoretical point of view, but it will work anyway, it will give you the same result. Okay. But in some cases, it may not work correctly, so it's always better to count a primary key. Okay, now I save. Okay. Build a query which shows the list of employees, first and last name, together with how many orders has that employee handled. Okay, you can do it alone, you can stop the video and try to do it alone. Okay, let's do it together. I close the previous query. Create. Well, let's use the wizard. Wizard. From table employees. Last name, first name. From table orders. Since I have to count, I will take the primary key, order ID. Next. I don't click here. Next. Query 22. Okay, now we'll group by last name and first name. Okay, usually you don't group by more than one field, but in this case, Nancy Davoglio is the same person. And I will count order ID. So I will totals, group by last name and first name, and for order ID, I will count. And here you can see who is working in this company, or Peacock Margaret, the oldest one. Okay, build a query which shows the list of employees, and for each one counts how many orders has that employee handled in 1996. Okay, try to do it alone. Let's do it together. I close. Yes. Create. Well, I use query design, employees, and orders. Close. Last name, first name, order ID. In 1996, so I need also order date. Okay. Totals. Group by last name and first name. Have to count order ID, and for order date, I have to force it to be 1996. We have seen in the last lesson there are several ways to do it. Let's do it with between, even though it's not my favorite one. Okay. However, even though this may work, I don't know. Let's see. Let's see whether it works. Okay, everything seems okay. I'm grouping by last name, first name. I'm counting by order ID, and for order date, I've set the condition here. Doesn't work, as you can see. It has not grouped by person. Why? Well, because you can see here there is group by. So not only I'm setting a criteria for order date, but I'm also grouping by order date. And in fact, if you see here, it has grouped the two orders handled by Stephen Buchanan on the 6th of March 1996. Okay, so it is grouping by order date. But since all the order dates are different, you have a lot of 1, 1, 1, 1. This is not what you want. You don't want to group by order date. You are using order date only to put a criteria, not to group. So in this case, well. And you can see here, in fact, that using where and not group by whenever you have a condition. So whenever you have a condition, you must use where and not group by. In this case, if you use where, the field is used only for the condition and for no other reason. You can see also show disappears. If you use group by, condition works, but the query is grouping anyway. I consider it to be a severe mistake if it doesn't work. There are many cases in which it works anyway, but because you have been lucky. In that case, I will consider it a small mistake. Okay, so this is what we want. So where for fields for which you want to put just a condition. Okay, so summary queries are pretty easy. Honestly, this is everything you need to say. We need to say. So there is here a field. You choose what you have to do with this field. Okay, you can choose where if you're putting a condition. You choose group by if that is a field which does the grouping. So it's rather easy. Let's do a very difficult example. Is it a very difficult example? Yes. Build a query which displays the list of orders, so order ID, and for each one calculates the total value of the orders, which is quantity by product's price by 1 minus discount. Everything summed up. So let's review it. First of all, in order to explain it clearly, I need here the relations. So can you see that for each order you have several details? Okay. So for example, order number 773 has 20 apples, 1 watermelon, 3 bananas, and whatever. Okay. So I want to know the total value of the order. So you have to make 20 by the price of apples plus 1 by the price of watermelon plus 3 by the price of bananas. And you have to sum up everything. Something which is in practical application is done regularly. So you have to find out the total value of the order, multiplying unit price. Well, it doesn't matter whether you use this one or this one, okay? By the quantity, applying the discount. In this way, you will find the price of each item, of each type of item, and then sum everything up. And in this way, you will find the total value of the order. I suggest you first to build a simple query which find the price of each order detail and then sum up. Try to do it alone. It is not easy. Okay, let's do it slowly together. First of all, I close this query here. Query 14. No, query 23. Okay, create. Well, I use query design. You can use query wizard if you prefer. I need orders. I need order detail. Well, now, if you take price from order details, you don't need products. If you take price from products, you need also products. This thing doesn't change. Well, let's take price from products. At exam, I try to give a database which does not have this one or this one, so you don't have this ambiguity. If I forget, use any price you want. Okay, so we need the order ID because we want to know which order is it. Then I need to calculate here quantity by unit price and apply the discount. So I call this field value. It is quantity by unit price. And how do I apply the discount? You should notice better than me, open round parentheses, 1 minus discount. Okay. This is the value of each individual type of object which is present in the order. Okay. You will see that we will have a problem. I anticipate to you. I try to switch to datasheet view. Okay. The specified field unit price could refer to more than one table. Well, because unit price is here, and the poor computer doesn't know which one I'm referring about. So how can we tell him? Well, either you remove this table completely, and now it's obvious that it's this unit price, or if you prefer, you specify the table name, products exclamation mark. It's very similar to Excel, in which you use sheet name, exclamation mark, name of the cell. Here you use name of the table, exclamation mark, name of the field. Let's see whether it works. Okay, so you can see that for orders 10 to 8, 5, it's not in. I will just for you. I will put it in. It's not necessary, but I will put in ascending order. So for order 10, 2, 4, 8, we have 3 type of items. We don't know which one, but one is worth 252, one 140, 174. For this order, we have only 2 type of items. For this order, again 3. For this one, 3. For this one, 2, 3. This one again, 3. Is it possible that my Excel is always locked? Okay, so now what we have to do is calculating the sum of these 3 things, grouping by order ID. So if Excel reacts, come on, I try to shut down something to see whether it's faster. Okay, so now I switch to summary query. I group by order ID, and I calculate the sum of values here. And I have for each order the sum of all its components. Exactly, here there was an example how to do it. Save this query with name my last query. Save it with save my last query. If you have already saved it, you can always right-click rename here. Okay, let's see what we have to do. Extra exercise. This is the reason why I have to save. Modify the previous query in such a way that it asks the user for a year, and for that year display the sum of the total values for each customer. So exercise is becoming really nasty. You can try to do it alone. It's rather easy. It's the cross with something we have already done. Okay, let's do it together. So I reopen it if I find it. My last query. Okay. Okay. Now I need the year order year. Year of order date, and in this way I get here the order year. It should ask, so please tell me a year, and it's not group by, it's where, because I'm using this only as a condition. Let's see whether it works. 1995. I don't put 2003 because we don't have orders after 1996. It's an old database. Okay, we have everything from 1995, 1996. Let's check 1997. I think we don't have orders. In fact, it's empty. Okay, so I don't save because I think we need it later. Okay, and now we change topic. Report. A report is simply a query or even a table. Okay, so you can build reports starting from tables or from queries. Simple reports start from tables. More complex reports start from queries. Okay, in a good-looking format, nothing else. So simply your table or your query result in a good-looking format. Okay, nothing else. Let's see how can you do it. What can we do it? Build a report which shows the list of products grouped by category from cheapest to most expensive. So reports are built in create. Where is report wizard? Here. You can see you can take start from tables or start from queries. In this case, we take category name and product name. Where is product from table product? Can I take from table product? Product name. I need also the price because I need to sort by unit price. Okay. Next. Okay. X-axis is asking you whether you want it in this way or in this way. Since I wrote group by category, obviously you want it in this way. Do you want other grouping level? No, because it's written here, grouped by categories. Okay. I want, however, sorting from cheapest to most expensive. Next. Unit price ascending. Next. This is only a static, whether you want it to appear in this way or in this way or in this way. Okay. Step it. Next. This is only, okay. Let's call it report 1. This is how the report looks like. This is the grouping by category. All the products in that category. It's really annoying, this access, which, oh, okay. All the products, again, stack by category in price order. The condiments, etc., etc. Okay, if you make something wrong, you can, it's the best choice usually, it can sell everything and redo it. But you have also the opportunity to go to close the print preview, okay, and go here. This is a sort of you have the design view and the report view. They are very similar. This is the report view to design view if it arrives. We don't have, oh, sorry, report view, oh, design view and layout view, sorry. Okay, they are to change the aesthetic of the report. Okay, here you can move your fields on the right, on the left, make it smaller, larger, whatever. But important, you have group and sort. Okay, here you can check whether you're grouping by category and whether you're sorting by unit price. If you want to add further grouping or sorting, you can click here. But usually, honestly, the best choice is to cancel everything and redo it. Okay, let's close the report. Build a report which shows employee by employee the list of orders with a total value. Okay, you can see if you try to build this report starting from tables, you will never manage to do it, because how can you calculate the total value? Okay, so whenever you have to make calculation or whenever you have to apply filters, for example, all the orders from custom in Germany, it's absolutely necessary to build a query first. So first you must build a query which gives you the exact data that you need for the report, and then you build a report based on that query. In this specific case, we already have the query, my last query, and so we can use that query to build this report. Create report wizard, report wizard, report wizard. Directly from query, my last query, I take both fields. Okay, I group by order. Do I say group by order? Ah, no, employee by employee. So situation becomes more complex, because not only do I have to use the query, but I have also to use table employees. So back from table employees. Last name and first name. Let's put things a little in order here. Oof. Okay, fine, I have last name, first name, order ID and value. Next. Or I group by last name. Well, it will be perfect to group by last. Let's see whether you can group by last name and first name. Well, if access works. What happens? Okay, let's try. I try to group by, no, I can't group by two things. So I have to group by last name and then by first name. It's not optimal, but it's the only thing we have. Next. Okay, let's sort by, is it, no, we don't need to sort, but sort by order ID. Only static. Let's call it report true. Finish. Okay, Buchanan, can you see Steven is on a different row? Because in theory, if there were Buchanan, John, it will be John appear here, but and we have all the orders handled by each employee. Okay, Axel is always stuck. 22 pages of report. Okay, save it. You have to save these things because they are objects. Okay, you can see there is also the possibility to export it into Word and in fact export the report to RTF file. So you cannot really export it to a doc or docx file. I don't know why, since Microsoft is the producer of Word and Access, but you can export it to RTF, which is compatible with Word. So let's see if I remember how to do it. Here, more, Word, okay. The RTF is the extension. Please don't put it randomly, God knows where, but be sure to put it on your desktop. On your desktop. Okay. Okay, export is complete. Now I go on my desktop, I try to find here the report. I open it with Word to check, and you can see it's the report in Word. Then obviously needs to be a little adjusted here. Okay. Okay, now we change topic. We go to tables, more detailed overview of tables. Well, tables don't have simply a field type, but each field type has several properties. We'll not go through all of them, but just the most important ones. Let's see an example. And here's the database. Let's open table product. Well, if you want to open a table directly in design view, you just right click and choose design view. Okay. Let's see. Let's start with product name, which is show text. Okay, for show text, we have field size. It's used to further reduce the amount of variable characters. Okay, I just skipped the ones which are not important. Default value, in case you don't type anything, the default value will automatically appear. Okay. Require, whether this field is mandatory or not. Some fields must be mandatory. For example, employee first name and last name. I don't believe that your company doesn't know the employee names, okay, or employee birth date or hire date. So some or product name, it's required. Some fields must be required. Allow zero length, it's only for text. So if it is required, but you allow having zero length, well, it's as if it were not required. So. Okay, what is indexed? Indexed has three options. Oh, well, there's written here. An index speeds up searches and sorting on the field, but may slow updated. Okay, so you have three options here. Well, if access doesn't stack, okay. No, it means that it's not indexed. This is usually for fields which are not so important. For example, a field such as reorder level may be not indexed. Okay. A field such as comments or curriculum may be not indexed, so it's not so important. Or a field, even a field with higher date, employees higher date, is not so important. You usually don't make searches or sorting based on higher date. But fields on which you will frequently make searches or sorting, for example, first name, last name, product name, okay, must be indexed. You may choose between no, so no indexed, yes, duplicates, okay, it means that duplicates are allowed, yes, no duplicates, okay. Obviously, primary keys are always indexed, yes, no duplicates. Well, here the choice was duplicates, okay, it means that in this database you can have duplicated product name. Well, I will choose duplicates no, but it doesn't matter. Okay, let's see some fields for numbers. Here you have units in stock, integer. Well, you can choose whether it has decimal digits or not. Okay. The format is only static. How many decimal places? Okay. Default value. It means that if you don't type anything, the value here will be 0. And what you can see required is no. It means that you can skip it. Okay. Indexed is no. It means that we are not planning to do searches based on unit in stock. Validation rule and validation text are two things that we have not yet talked about. Validation rule. If you put a validation rule, whenever somebody tries to insert a new value, the value is checked against the validation rule. In this case, the value is checked to be positive or 0. If it does not satisfy the validation rule, the validation text appears. Let's do an example. I try to insert a new product. Blah, blah, blah. Supplier. Formaggi Fortini. Category. Grain cereals. Quantity per unit, 1 box. Okay, unit price, 5. Unit in stock. This has a validation rule. I try to insert -5. You can see, you must enter a positive number. Validation rule prevents me from inserting things which don't satisfy validation rules. Okay, let's see whether there are some other properties, field size, format, decimal place, default value, validation rule, validation text required. Okay, we have talked about everything. Okay, let's do some little exercise in particular on validation rules. So build a validation rule with appropriate validation text which checks that the product's unit price be larger than 1. Okay. So I go to unit price. Well, currently larger than 0, so you don't have to do much more because you must enter a positive number. The problem is now you must save because this is a structural modification. However, since unit price already has values inside, Access will complain, will tell you, but we already have values inside. What do we have to do? Data integrity rules have been changed. Existing data may not be valid. Do you want to check the existing data? No, don't do it. So there is the validation rule will be applied only to the new data. To table employees, add a new field email. Build a validation rule with appropriate validation text which makes sure that email address contains an @ Try to do it alone using like. Okay, let's do it together. I close this table here, table employees. I open in design view. Okay, I add a new field, email. Okay, well, if you really want, it's hyperlink. Okay, validation rule. How can I force email to contain the symbol @? Well, using like, I can write like, quotation, because you must use quotation, it's text, asterisk, @ asterisk. Email address not valid. Okay. Here you don't need quotation in validation text because it's automatically text. So if you try to type something which is not like anything followed by the @ symbol followed by anything, it will not be accepted. Honestly, if you want to be more precise, you can make something like this, .st, because you know that email addresses have always at least one dot on the right side. Okay. So this one will force you to have something, anything @ anything dot anything. Okay. If you want to be even more precise, if you write it like this, somebody could write an email address in this way. And don't write anything on the right, because the asterisk means anything including nothing. If you want to be even more precise, you can write something like this. This way you are forcing the person to write at least one character here, preceded by any amount of characters, at least one character here followed by any amount of character, the dot, and at least two characters here followed by any amount of character. This is if you want to be extremely precise. Now we have to save. Well, you can tell him to check. No, don't tell him to check, because since there are many missing email addresses, required no, so he will not complain, I think. Ah, no, okay, he's complaining. All the missing email addresses don't satisfy this validation rule, obviously. Okay, this is what we have done. Add a new field zip to table employees with a validation rule with appropriate validation text, which checks that zip contains exactly 5 characters. You can do it alone. Let's do it together. So zip, it shows text 5. This is not enough, because this means maximum 5. We want it to be sure that it contains exactly 5 characters. 1, 2, 3, 4, 5. Zip code must contain exactly 5. If you need it in your future life, there are much better symbols which, for example, force the zip code to contain exactly 5 digits. Okay, but they are beyond the scope of this course. Okay, now look here. I ask you to build a validation rule which checks that employee's hire date be later than employee's birth date. It seems easy, but it's not. Let's see. So you go to hire date, and you say validation rule later than birth date. Okay. Because obviously the employee must be first born and then can be hired. So employee is not born yet. Okay. However, I am sorry to inform you that this thing here doesn't work. It doesn't work because you are not allowed to put other fields in a validation rule. It doesn't work like a query in which you can put other fields in the criteria or other fields in the calculation field. No, here you cannot put other fields in the validation rule. So, doesn't work. Let's see what happens if I try to. Okay. Invalid SQL syntax. Okay, so it doesn't work. We have to remove this thing. So how can you put a query? Yes, yes. A query like this one. Sorry, a query, a validation rule like this one, which involves 2 fields. A validation rule like this one must be put here. So pay attention. Table tools design, property sheet, validation rule. This is a table validation rule. So a validation rule which is valid for the entire table. And here, well, it's much better to use the higher date. Larger than birth date. Okay, validation text, employee must be born. Okay, save. Yes, yes. Okay. Okay, so this one works. If you don't believe me, let's try to change the higher date here to it was 94 to 64, so before her birthday. Okay, look, I press tab now. No complaining, because this is not a field validation rule, it's a table validation rule. It will be checked only when I'm finished. So when I go to another record, it means that I'm finished with record number 9. It will tell me employee must be born, which is not very helpful because it doesn't tell me which field is wrong, but okay. Modify the previous table validation rule to check that employee's age is at least 16 when it was hired, when she was hired. or here you have to use date diff or date add, as you prefer. It's written here. You can build an approximate calculation or an exact one using date diff or date add, as you prefer. We will do all three. So, do what you want. Stop the video and do what you want. Okay, now we'll do it together. First of all, the approximated calculation. So the approximated is very simple. Higher date larger or equal than birth date plus 16 by 365.25. A dot is not valid. Comma 25. Okay. This is the fastest one, but it's approximated. Another one using date add. Okay, so here I use date add y 16 birth date. So it's exactly the same as the other one, but here I add exactly 16 years. Okay. Finally, the last one is honestly the most logical one. You check that the difference between birth date and hire date is larger than 16 or equal. As usual, Excel is stuck, Access is stuck. Date diff in years between birth date and hire date is larger or equal to 16. All three are equivalent. The first one is approximated, the second and the third are perfectly equivalent. Okay. And we are over with table validation rule and things like that. Now I don't save these things here, so no, I don't want to save the changes. Okay. Let's go on. Importing tables. Well, you can import also tables from text file, from several other sources. Honestly, I suggest the following. If you are planning to import a table from a strange source, import it in Excel, check in Excel that everything works correctly, and only later import it in Access. Because Access is very, very, very complaining when importing tables. Okay. Let's see. Import, do we have an example? Oh, we don't have example.xlsx. We will import table wine, for example, here. Read only, use. Okay, it's a table of wines. Let's remove producer. You can see why it's a good idea to check carefully that everything matches. Okay, when you're sure. Why is it read only? History. We'll import it anyway. So, external data, Excel. Because you can import from text, but I don't suggest you import the text into Excel, check, and then import it. Okay, browse. Where is my directory? Okay, found it, wine. Okay, import the source data into a new table. Okay, this is easy to do. I try to do this for work myself. It's a nightmare because the table that you're importing must match exactly the existing field of the table here, and you must have the primary key, and the primary key values must be correct, they must not overlap. It's a really nightmare. So this one is usually the easiest choice. It suggests you whether this importing is okay. Well, seems okay. First row contains headings, yes. Okay. In this case, I suggest you to go really one by one and choose. This show text, indexed. Well, yes, duplicates, okay. Show text, indexed, no. It's an integer. It's an integer. It's currency. Well, let's index it just. Excel is stuck as usual. Okay. Producer, we skip it. Okay, you can see you can skip next. Okay, access has detected that there is no primary key. You can decide that a field be a primary key, but please choose a field which can be a primary key. In this case, no field can be a primary key, so we will let access edit the name, close. Here, in case, pay attention because here you will see whether there are some mistakes. In this case, no mistake at all, luckily. Okay, and the table appears here. The table is here. See the structure. Okay. Okay, let's go on to relations. Well, can we see which relation exists in the database? Okay, there is a place in which you can see all the database relations. It's here, external data. No, sorry, database tools, relationships. Can you see here? You see all the relation. Pay attention because in this schema, sometimes you don't see all the tables. For example, look, wines, it's a table of database, but it's not present here. Sometimes you see some tables doubled, so don't trust the schema too much. Right click and choose show all if you want to see all the tables. Okay, you can see wines hasn't appeared. I don't understand why. Maybe it's hidden. No, it really hasn't appeared. So right click, show table, and explicitly get wines. And okay. Okay, so don't trust too much the schema. Some tables may disappear suddenly. Okay, so you can see the schema. You can see all the relations automatically. If you want to destroy a relation, double click on it. You can see that the relation is one-to-many with referential integrity enforced. It means that if you try to delete something from table categories, Access will not let you do it because you are going to destroy the referential integrity of table products. Okay. So, but you can, if you want, remove the relation, delete. Okay. Let's redo the relation. You just take out the field and drag it above the other field. Please catch the two fields. Don't drag it randomly somewhere. Access guesses usually correctly, one-to-many. Enforce referential integrity, create, done. If you don't enforce referential integrity, this is what you will see. You will not see the symbols 1 and infinity. Okay. This is the way to create relations using the relationship diagram. It's the most, let's say, the way for which you have an overview on your database. Okay. There is another way using a lookup wizard, which is more complicated but makes a better more user-friendly database at end. Okay. What I'm talking about? I'm talking about the fact that, for example, open products. When you go here to supplier, you have a drop-down menu. Okay. Also for categories. If you build a relation without if you build a relation from the relationships diagram, usually you do not have this wonderful drop-down menu. Okay. Let's see. Relationship diagram. As usual, table wines has disappeared. Show table wines. Suppose I want to, let's see, make a relation. Well, it's rather difficult because from field, let's insert a new field, supplier, and make a relation with table suppliers. So I open table wine. You can open it directly from here. Supplier. And this is not show text, it's number, because the relation with the primary key, and on the other side the primary key is a number. Okay, save. Okay. Now it has the supplier. Now I create a relation with supplier ID, enforce referential integrity, create. The relation can usually exist. Okay. But when you are in table wines, here, and you try to insert supplier, you can see you don't have the drop-down menu. And you have to remember by heart that supplier for Maggi Fontini was 35. The other one was, oops, 30, 35 is not even present in table supplier. You have to remember by heart all the primary keys of table suppliers. So all these primary keys. So 6, 4, you have to remember by heart these numbers. It's very, very user unfriendly. So how to build a drop-down menu here? First of all, we remove the relation. Okay. Now we go to wines table, table supplier. Instead of number, we choose Lookup Wizard. Lookup Wizard, it's a little automatic tool which lets you at the same time build a relation and build a drop-down menu. I want the lookup field to get the values from another table, from table suppliers. I want to get the company name. Pay attention because the relation will be created with supplier ID. Okay. But here you just select what appears in the drop-down menu. Next. Well, let's sort them ascending by company name. This is what will appear in your drop-down menu. Do you want to enable data integrity? Yes. Finish. The tables must be saved. Yes. Okay. So now you can see that at the same time I have the drop-down menu. And if you go to relationship wizard and ask show all, you see also the relation appearing. Okay. So the lookup wizard is a little tool which lets you at the same time build a drop-down menu and a relation. Much better than building the relation here. However, the lookup wizard has another feature. It lets you specify a predetermined list. What do I mean? Go to table employees in design view. Title of courtesy. Well, title of courtesy, suppose I want to fix a list of possible title of courtesies, and the value must be taken from that list only. Okay. I have two alternatives. One alternative is using the lookup wizard. I will type in the values that I want. Mr., Mrs., Miss, Doctor, and stop here, next. If you click limit to list, you are limiting the values to this list only. If you don't click it, the list will appear as a drop-down menu, so will make the life easier for the user, but the user can type other values. Okay, so limit to list now, for example. Finish. So now, whoever inserts a new value is limited to this list and cannot add new ones. Okay. I hope it will prevent. Okay. Okay, if you don't choose limit to list, it's just a suggestion. However, even though this is nice because there is a drop-down menu, etc., if you do something like this, it's hard-coded into your database. It means that if you decide that a new title, for example, professor, must be present, you must call a technician which changes the structure of your table. Okay. How can you be more flexible? You can be more flexible exactly in this way. Categories and products, category ID, take values from table products. This is exactly the same way as title of courtesy, but here the values, the possible categories, are not hard-coded into table products, but are taken from another table. So you can do the same thing here if you want, and I suggest you to do it as an exercise. So build another little table with titles of courtesy, with all the list of title of courtesy, and take the values from this table. It's a more flexible solution because if you need a new value, you can, simply add a new record to the table. For example, here, if you need a new category, you just can add a new record to table categories. You don't need to change the structure of a table, which is always a technical thing. Okay, do it now in this way. Build a new table called grades with a mandatory list of verbose grades, bad, sufficient, average, good, excellent, and relate it to a new field, grade, in table employees. Do it. Okay, we do it together. Close it, close it. Let's close everything. A new table. Creating a new table, I suggest always create it in table design. Don't use the width, the table. Oh, the table wizard, I see that finally it has been. Yes, table wizard doesn't exist anymore, finally, because it was really stupid. Table design, field name, ID, auto number, grade, show text. Well, let's say 20. Okay. Required, yes, otherwise, why does it exist? Okay, this is the primary key. Done. I save. Grades. Done. Now, from employees, I build a new table. Grade. It's Lookup Wizard. Maybe before it's better to assign some values to grades. No, let's do it later. I want the lookup field to get the values from another table. Next. Grades. Next. I want to see the grade list. Okay, well, this is what you will see. Nothing, because for the moment table grades is empty, but we will fill it, don't worry. Next. Enable data integrity. Yes. Okay, now we have forgotten to fill table grades, so let's fill it with good, no, sorry, bad, average, sufficient. Well, according to your opinion, sufficient, maybe sufficient here. Good, very good. Okay. I don't save because I just am inserting values. Can you see? From table employees now, for each employee, I can assign a grade and I have the drop-down menu. If the boss decides that he needs also the very bad grade, since we have used this architecture, it's very easy. You just open grades and you add the very bad grade. Okay, and now in table employees, you have also, well, no, we need to close and reopen. Very bad. Okay. So if you want to have a predetermined list, well, it's better to take the values from another table rather than building it from the Lookup Wizard, because otherwise it will be sticked and you can't add other. It's very difficult for you to add new values. Okay, last thing, forms. What are forms? Forms are little user interfaces to make your data entry and data editing easier. Well, honestly, you could avoid using them altogether if you want to insert data directly into tables. Most of the time, however, people who work on a database are not expert, and if you let them insert values directly into a table, they may create disasters. So it's better to have a form. Let's see. Build a form to insert, modify, and delete employees. Create, where is form wizard? From table employees. Let's have last name, first name, title, title of courtesy. Where is the picture? Country and photo. Okay. So you can select only some fields. It means that the person using this form will not be able to modify the other fields or to insert the other fields. Will be limited to these fields only. Next. How will the form look like? It doesn't matter. Next. Let's give a name, form 1. And this is how the form looks like. Because you can go through the people one by one. You can modify the people. Any modification you do here will be automatically reflected in the original data, so pay attention. Right, the drop-down menu doesn't work. Probably my axis is, as usual, my axis is stuck. Okay. You can also insert new people if you want. Okay. But pay attention, if you insert a new person, not all the fields will be available, only the ones that you see here. So you are limiting a person. Okay. Let's see a little more complicated. Build a form to insert, modify, and delete orders with their details. Here we are building a form to modify things from 2 tables. It's possible to do it. Create form wizard, orders, order ID, order date, required date, and what else? Ship country. And from order details, product ID, unit price, quantity, and discount. Next. You can see it will look like this. Better like this. Next. Form 2. Here you can see since we are taking data from more than one table, you have practice building a form and a subform. The form are the data from order table, and the subform are the data from order details. Finish. Can you see? The form is here and the subform is here. They have 2 independent bottoms. So this one to go order to order, the order to order, and this one is to go element to element. So a form with a subform. Okay, let's close them. You can apply a restriction to your forms. Well, we don't even talk about aesthetic changes. They are really very stupid. There is a menu with design view which lets you do aesthetic changes. You can, however, apply restriction to your form, so you can limit what a person can do. Let's see. For example, let's limit this form here to only insert new employees. So the person using it will not be able to delete employees and will not be able to modify existing data. So I open form 1 in design view. If you want to do any aesthetical change, it's here that you can do them, but we are interested in the property sheet. Okay. Pay attention, go to data, be sure to be on form and go to data. allo additions, allo deletion, allo edit. These are the 3 fields that we talk about now. We don't talk about data entry. So allo addition, yes. Allo deletions. Can't the drop-down menu appear? No. And allo edits, no. This means that the user will not be allowed to delete people, edit people, but only to add people. Okay. I will reopen it again because I don't trust access. Okay. Especially at exam. I switch to form view. Just to give you an example, I try to change the volume. Doesn't work. I try to insert a new record, you can. But if you try to delete the existing record, can use it to delete the record here has disappeared. Okay. Okay. I am asked to save because I did structural modification. Okay, finally, build a form to insert categories and insert modified products inside. So I'm asking you to build a form with a subform, categories and products inside, but for categories you can only insert. And for products you can insert and modify but not delete. Let's do. First of all, we build the form. You can try it alone. Okay, together. Create form wizard. Categories. Category name. Also the picture. Products. Product name. Unit price, unit in stock, and units on order. Next, it will look like this. Let's call it form 3. Remember also the name of the subform, or let's call it subform 1 so we don't subform 3 so we don't make confusion. Finish. Okay, a wonderful picture. So you can see the beverages, the condiments, the dairy products, no, confections, dairy products, grain cereals, meat, produce, etc. Oops, I clicked too much. Okay, now let's apply the restriction. In order to apply restriction to the main form, so to categories, as usual, you go to design view, you click on property sheet, and you decide, let's review, only insert, so you remove deletions and edits. Let's check. Okay, it works. In order to apply restriction to this form here, however, I strongly suggest to do the following. Save, close, open the subform directly in design view, and the modification must be done only on the subform. If you do in another way, if it works, good for you. If it doesn't work, don't blame me. Okay, here what do we have to do? Insert and modify, so we have to remove the deletions. Okay, prevent deletions. Okay, and now close and save it. Let's check if you don't trust yourself. I try to delete Chang. Well, I can't. Okay, but if I want to edit Chang, oops, oh, I should be able to do it, but okay. So the restriction on the top form also extends to the lower form. Okay. However, we have put we have learned that any restriction you put on the top form will extend to the lower form, okay, but not vice versa. So we can do an exercise like this. You can, but do an exercise like this. Okay, let's redo. Insert and modify on the upper form. Addition and edit. Okay, I close it, save it. On the subform, property sheet. On the subform, okay. So now we have insert and we can insert and modify categories and only insert products. Let's see whether it works this time. Okay. Can we modify categories? Yes. Can we modify product? This is not permitted. Okay, no. Okay, so any restriction you make on the top form will extend automatically to the lower form, but not vice versa. So the lower form you may put additional restriction using the subform here. Okay, and the course is over.